Welcome to Ask and Learn.
Let's talk about this question. Two automobiles, each of mass 1000 kilogram, are moving at the same speed of 20 meter per second when they collide and stick together. In what direction and at what speed does the wreckage move if one car was driving north and one was south? So let's talk about part A. One was driving towards north and one was driving towards south. So this is mass m, this is mass m, and when they collide, they stick together. So when they collide and they stick together, that's going to be of mass 2m. So we're going to conserve the momentum. So the initial momentum is going to be equal to the final momentum. The initial momentum will be mv, because this is moving with v and this is moving with v as well, but in the negative direction. So mv minus mv is going to be the final momentum. Final momentum is going to be 2m times the net velocity afterwards. But mv minus mv is just zero. It means that they don't move at all. The wreckage stops after the collision. But if we talk about part B, the directions are changed a little bit. In part B, they are saying that one of the car is moving, is driving north, so it's like this, and another car, and one of the car was driving north, and another car was driving east. So east is over here, and then they collide somewhere. After the collision, they stick together. So again, we are going to conserve the momentum. So the initial momentum is going to be equal to the final momentum. So the initial momentum is equal to the final momentum. Initial momentum, momentum is a vector, we have to remember that. So the initial momentum is going to be we can divide the equation in two parts. One is towards the x-axis. Let's conserve the momentum towards the x-axis, because let the wreckage have a vx velocity and vy velocity. So if we conserve towards the x-axis, then we are going to say that mv, because that is the only momentum towards the x-axis, is going to be 2mvx. So the value of vx is v over 2. And likewise, towards the y-axis, we are going to use the same equation, because again we have mv, because this is also moving with the velocity of v and I have a mass of m, and this is going to be equal to 2mvy. So vy is going to be again v over 2. So the final velocity after the collision looks like v over 2 in this direction and v over 2 in this direction, and v is 20. So 20 over 2 is 10. So it's moving with 10 meter per second and 10 meter per second. Since both are same, so the angle between them is gonna be 45 degrees. And let this be the v dash be the net net magnitude. So v dash is gonna be equal to 10 square plus 10 square root, as they are both at 90 degrees. So that's gonna be 10 root 2 meter per second at 45-degree north of west. Thank you.